video about the Mercury 6-cylinder inline ignition systems. We started off with 2 automotive type coils with resistors to drop the voltage and a ball bearing 2-point system, because we were firing a 2-stroke engine which required as much firing as a 12-cylinder 4-stroke. So this 6-cylinder allowed the voltage to build long enough to make these ignition systems fire. That's why they had 2 coils and 2 points to allow the ignition build. It was a battery-driven ignition. It was not a magneto, it's battery-driven. And the solenoids for the starters were standard solenoids, just had the start circuit and over here a ground, and it was connected up that way. And these resistors were enough to cut the voltage down while it was running so the points wouldn't burn up, but not too much resistance, and allowed enough voltage to get through for the engine to start. But since this was a direct reversing engine, they wanted it to be able to start well in reverse, so they were always struggling with how to make it start better. So by the 78A direct reversing and the Merc 700, the Merc 800, and the 600 direct reversing engines, they started using an ST type solenoid, which puts 12 volts to the ignition system only during the cranking cycle. There's a second, it's internally grounded to this plate, and externally it has 2 terminals, one of which feeds that 12 volt into the ignition system while the engine's starting. Okay, so that was the improvement they made to make them start better. Did they start any better? No, they still called them dock smashers. And what we used for setting those points for that Mark 78, this was the latest plate. This was for the standard ignition. You use the plate and you use the Mercutronic over here on distributor resistance. And we also used this older item, which was a milliamp meter, and that works the best of any of them as far as I'm concerned. All right, so the next thing we went to was in 1965. I was at school and down at Mercury School down in Auburn, not Auburn, excuse me, it was in Rhode Island, in the capital of Rhode Island. What's the capital of Rhode Island?
Providence.
Providence, yeah, it was in Providence. And they had a brochure there, even though everything was standard ignition at that time. They had a brochure for this Thunderbolt ignition. And this is the Thunderbolt ignition. Same distributor, except that it had maker points. And this is where you set them here with this Thunderbolt ignition, as you can read it right there. And it had a switch box with a condenser in it and 1 terminal. These are your input sides, and this is your output side, or the sensor side. And these 2 points will hook together on that 1 cylinder, on that 1 indicator. So the ignition in here, battery-driven ignition in here, would fire this coil. And these had to be adjusted correctly. And that lasted, I think, a couple of years. So that would have been first maker, would have been around 66, 67. Mercury's new year started the 1st of August every year, so it's sometimes a little confusing to tell what year something is. Then the next thing they went to was a Hall effect sensor, and they had, you can see it right here, this rotates, and these holes change the magnetic flux between a magnet and a winding, and then it sends a signal out through the 3 wires. One of them is ground and two of them on one side of the signal and the other side of the signal. I'm not exactly sure how they worked internally, but it is a Hall effect sensor. Originally, the pass plates looked like this. And as you can see, if you look very carefully, you can see they're a little bit different sized. Like this one right here is a little bit smaller than this one. That was to change the timing slightly. Then they went to a much bigger hole. And those holes also are slightly different sized because some cylinders ran a little bit hotter than the other, so they would slow the timing down in individual cylinders by these holes here. Very important that these be installed the right way up. Later on, they started marking them this side out, but on the earlier ones, they didn't. And it's very important before you work on one that you scratch this side up or out or whatever you want to put on it before you take them apart. And
What was the reasoning for having one side priority versus the other?
Because the holes are set for different cylinders, right?
Yes. These holes are for each cylinder.
This is keyed.
And if you flip it over, yes, it's keyed.
Yeah, it's keyed.
Exactly, it's
Okay.
keyed.
Yeah, yeah.
And if you flip it over, your timing is going to be off.
Yeah, I see that now. Yeah.
Okay.
Yeah.
All right, and this is the housing. These were relatively serviceable. They were screwed together. You could take them apart, and you didn't need to destroy any bearings. These worked fairly well. Saw very few failures. I wasn't around. I was in the military at the time this thing was prevalent, but to the best of my knowledge, these things rarely fail. These switch boxes really fail. This is what they called them, a switch box, CDI box, whatever. They're all battery driven. They require 12-volt battery in order to operate, just like the older system did. And this is what it used for a distributor cap. You can see it's really the same distributor cap they used on these older ones, just the second pickup has been blanked off. Couple of differences here. You can see the drives are different. I believe this came off of one of the last ones to use this. It was a Mercury 110 or a 100, 1967, 68, something like that. That was the more common one that I've seen. I'm not sure exactly what engines it was used on, but there are a couple of different ones. And these are basically the end of this distributor. What are these things called? Rotors? Rotors. You do not want to grab onto these rotors. They're plastic cast onto the shaft, and if you wrench them, they don't like it. They'll just twist inside. But they are not like a car one. They are not. They don't pass current. In other words, you don't need to replace these like you would in a car. The plastic they use does not conduct electricity. It doesn't have carbon in them like the car ones do, which can conduct electricity, and you do need to replace them more frequently than these. These rarely cause any trouble. Like the same thing with the distributor cap. These tan distributor caps, there were white ones, there were blue ones that I'm aware of, and I think even red ones. They were all okay. The black ones, or dark green ones that Mercury had, they do conduct, and they aren't really something you want to use. Any questions so far?
I'm working on it.
You're working on it, okay. We're getting down to the ignition system that you know a little bit better.
So what year are we up to so far?
We're up to the late 60s, probably, early 70s now. I'm not exactly sure when they stopped using that distributor type Hall effect sensor, but they went to this type right here, which isn't anywhere near as easy to work on because you have to disassemble this whole arrangement here, and then you have to pry the bearing off the top in order to undo a nut that's underneath it to pull the whole thing apart. I'll do that one of these on another video, but they're really miserable to work on. These, when they first came out, worked fairly well. We didn't really have any trouble with them. but along about 1976, I had one 115. I replaced 6 or 7 in one summer. And I was not the only one by any stretch of the imagination. And they were horrible. They had a problem with production somewhere along the line. They had us put ground straps on them. They had us do all kinds of weird stuff, and none of it worked. This was the tester.
Turn that radio off. Can you turn that radio off?
I can. I locate it.
Oh, I'll turn it off. Here we go.
Thanks.
Okay. This is the tester they gave us to test these newer ignition systems, starting with the oldest one. We called it the mushroom tester. This is the flow sheets they used to give us. That would be a picture of the flow sheets that came in a little blue manual, and you had them for all the different systems. And we called it the mushroom tester because Mercury didn't tell us how anything worked. They just kept us in the dark and fed us horse shit. And so that's why we called it the mushroom tester.
That's like your military service.
Yes, exactly.
Hey, did it come in this really cool Mission Impossible case?
Yes, it did.
Wow.
And it had even had a Mercury label on the outside.
And it was impossible to use.
And it was, well, it worked.
Oh, okay.
It worked, but it would not test the problems we had with the triggers.
Huh.
You just had to know from experience that it was the trigger, and after a while, you didn't bother to even get the tester out. You just replaced the trigger, and the thing would work again. But you had all these wires you plugged in, all these different colored wires. They were missing a couple here. I think we had white, red, green, blue, purple, and you plugged them into all these little places, and then you had these little switches you worked, and you set it on a different setting for it. And then these little lights would blink up here. You crank over the engine. It told you how to do all this on the sheet. What things to plug in, connect black test lead to C-jack on analyzer and either brown switch box wire, blah, 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 blah. So on and on you go. And then as time went on, they had some additional things. This right here was an adapter that you plugged in here so that you could use this meter for testing the later ignition systems, which I'll talk about later. But they finally gave up on that because it was so complicated hooking up all the wires that they just finally went back to a standard DVA meter, which I'll show you over there for that when we get to it. All right, so we had this type of distributor. Initially was pretty good, but as time went on, it was not so good. Again, you could see the difference in the size of the openings right here. See that one's smaller? This one's wider. Typically that was number 2. They would give it less timing because number 2 liked to heat on a 6-cylinder inline. Mm-hmm. Don't ask me why, whatever, something internal. Here's a different rotor. Different color, blue, still perfectly good. That was obviously replaced at some point. This is one other thing I want to talk about here. Typically you run into a distributor that's like this from a 75 and up, and you look all the way around the band here, it's clean, more or less, other than the vent. You look at this one, and you've got epoxy and epoxy. That was epoxy dot. Those were the replacement triggers. They seem to work pretty good. We had pretty good luck with those. Typically, we ended up with this, I think, around 79 when they were phasing out the ignition system. That was the replacement unit, and it seemed to work pretty good. Towards the end, they also went from this coil right here, this giant red coil, they went to a black coil, a little tiny one. And same, they're interchangeable, these two are. Couple of things. If you see on this rotor, there's a narrow opening and there's a big fat opening. Some of them just had a narrow, that would have been a 6-cylinder. If they had both, it means they were interchangeable and you could use it on a 4-cylinder. The opening's larger, but again, you got to make sure that those plates stay marked. This would be, they used this ignition system, the earlier one, on some of the smaller engines as well as.
Now these shudder discs, they're pretty fragile. So you really don't want to get in there and
These are okay. The thing is, I don't have
do
one
any
apart.
prying or anything like that and distort it.
This is a different type from off an 850, but the bottom bearing is held in by a circlip. So in order to get to that bearing, these would break sometimes and drop down and allow the shaft to go inside. In order to replace this bearing, you had to, the shaft is sticking up through the top, and these holes right here, you'd stick a screwdriver in, and you'd pry the upper bearing that's sitting up here. I don't know if I can, yeah, there's one right there. You can see it right there. You unscrew this cap,
Yeah.
and you get everything off. You pull all this stuff off of here, and now you've got basically this piece right here with the shaft sticking out of it and the bottom looking like this. And you pry that upper bearing out. There's no way to get it out other than to pry it out with 2 screwdrivers, and in doing so, you ruin it.
Yeah. You
So you have to replace it.
Yeah, you ruin the seals. Yeah.
Right. So that's a painful deal. Okay, so now we move on to, I'm going to do another one on, I'll include the 4 cylinders, why not? Okay. 4-cylinder, they used the older system, and then they went to, on the 85, they used this system as well for quite a few years, up until 76, I think. They came out the 850, 4-cylinder 850, for some reason was the first one to go to a switch box. The 6-cylinder 90 was the first one to go to the newer ignition, and that was in 79. So the 850 had a system, which I do believe this coil came from. I'm missing the unit that screwed into here. You didn't have to replace the whole thing. And it had a different switch box, and they worked great, except that if you did not have the ground hooked up, they would fry instantly. So if you hooked up the wires wrong, they were done. But this is the system they used, or they used this type of a system, exactly the same, except with 4 holes instead of 6. And they would have this type of distributor cap. These all changed the distributor caps to this type. The 6-cylinder would have 6 of these teeth on it instead of 4 like this one, but in a band that held them on, which was kind of a miserable piece of equipment
Yes,
to work.
that was not a
Awful.
easy.
Right.
Yeah.
So then last but not least, in 79, at least that was the first model year I saw it on, was on the 90 horsepower, 1979 6-cylinder, 90 horsepower. They came out with a new system, had 2 switch boxes, no longer battery driven. It was internal again, and it was driven by the alternator. This alternator right here charged the battery. This part of the alternator right in here had a high and a low speed winding, and it provided power to the switch boxes. And the switch boxes changed it to DC and stored it in a capacitor. Instead of having the battery charge the capacitor, they used the alternator to charge the capacitor. And then this, the flywheel had magnets inside as well as outside to charge. It had magnets inside, which would trigger these little windings in here, which would send a very low voltage to the switch box and tell it when to fire. When they first came out with them, 76 on the V6, 79 on the inline 6, they worked very well. And somewhere along about 1984, 85, supposedly the lady that was making these switch boxes put too short a wire on the board inside, on the electronic board inside here, and the cold weather would pull them off. Well, I happened to talk to an electrical engineer who was involved in the potting material, and these early switch boxes had really hard potting material, and the differential between in the wintertime in the north would literally rip components right off of these things. So these switch boxes didn't do well. They were not a good deal. In fact, I still am not crazy about them from Mercury Marine. CDI seems to do a real good job.
So back in the day, the recipe for avoiding that would be take the switch box off and put it in the house?
Well, I guess, but we didn't know that at the time. This, typically today, when you take this to a Mercury dealer with ignition that's intermittent on a cylinder, or you're missing it on 3 or whatever, these things have bias circuits inside of them, okay? What they do is they ensure the firing takes place. When this little trigger voltage comes into this switch box, it's an amplitude, it's a pulse, but it has a curvature over time. So typically you could fire the cylinder anywhere 20 degrees apart, and you obviously don't want that. So what they did is they have reverse voltage they apply against it, and it's called the bias circuit. And that's typically what goes to hell in these things and what blows the piston. They work with each other along with this. And if you replace one switch box, typically what happens is it blows the other switch box. If you replace both switch boxes and you don't replace this, the voltage either goes up or goes down, and this will destroy both switch boxes. So the rule of thumb is you replace these two, this and this all go together.
So there is no real shortcut remedy.
There's no money shortcut on the remedy for these things. And I can't, I still see them mostly on V6s, but on the 6-cylinder inline, all of them, these switch boxes, when they start going, they cause destruction, typically what happens.